Creatine and glycogen might seem like separate topics. One is the phosphocreatine energy system, the other is the carbohydrate storage system. But they interact in ways that have real practical implications for training performance and recovery, particularly for athletes in carbohydrate-dependent sports. Glycogen is the form in which your muscles store carbohydrate. It's your primary fuel for moderate to high-intensity aerobic exercise, and the energy source that the glycolytic system draws on when the phosphocreatine system runs low. Muscle glycogen content is one of the primary determinants of endurance exercise capacity. When glycogen is depleted, performance drops sharply. After exercise, your muscles replenish their glycogen stores from carbohydrates consumed during recovery. The rate of glycogen resynthesis depends on several factors: the availability of glucose, the activity of the enzymes that synthesize glycogen, and the hormonal environment. Here's where creatine enters the story. Several lines of evidence suggest that creatine supplementation enhances muscle glycogen storage. Studies using muscle biopsy before and after exercise. Recovery have found that individuals supplementing creatine show greater glycogen resynthesis rates during the post-exercise recovery period compared to unsupplemented controls. Given the same carbohydrate intake, the proposed mechanism involves cell volumization. When creatine draws water into muscle cells via osmotic pressure, it changes the intracellular environment in ways that affect glucose uptake and glycogen synthase, the enzyme responsible for assembling glycogen from glucose units. Swelling-induced changes in osmotic pressure and cell membrane tension appear to upregulate glycogen synthase activity and enhance glucose transporter function, collectively supporting faster glycogen repletion. A second mechanism is insulin-mediated. Creatine supplementation taken with carbohydrate produces a synergistic effect on muscle uptake of both creatine and glucose through the insulin response to the carbohydrate load. This combined enhancement of both creatine. Glucose uptake into muscle cells may explain part of why creatine supplementation during a carbohydrate-rich recovery meal produces better outcomes than either strategy alone. The practical implication for athletes who train multiple times per day or on consecutive days is significant. If creatine accelerates glycogen resynthesis, the window between training sessions becomes more productive. Athletes who need to perform again within 12 to 24 hours. Tournament players, multi-stage competitors, high-frequency training blocks are exactly the population where creatine's glycogen enhancement matters most. Faster glycogen resynthesis means more fuel available for the next session, and that gap compounds across a multi-day event. This is separate from and additive to creatine's phosphocreatine effects. The two mechanisms address different energy systems and different aspects of recovery. Combined, they make a compelling case for creatine's value in any sport where back-to-back performance quality matters. 5 grams per day, taken consistently, positions you to benefit from both mechanisms simultaneously. There's a subtlety in the creatine glycogen research that's worth understanding. The enhanced glycogen resynthesis effect is most pronounced in the early post-exercise window. The first 1 to 4 hours after exercise is when glycogen synthase activity is highest, and muscles are most receptive to glucose uptake and storage. If creatine enhances glycogen synthase activity and glucose transporter function during this window, consuming creatine with a carbohydrate-containing recovery meal in the immediate post-exercise period targets the moment when the glycogen resynthesis benefit is largest. This is one genuine evidence-based argument for post-exercise creatine timing, specifically because of the glycogen interaction, not just the insulin-creatine uptake argument. The magnitude of the glycogen enhancement from creatine supplementation isn't large enough to be the sole determinant of recovery quality. Adequate carbohydrate intake remains the primary driver of glycogen replenishment. But creatine appears to make better use of the carbohydrate that's available, getting more glycogen stored from the same carbohydrate intake than you would without supplementation. For an athlete trying to maximize glycogen recovery between 2 sessions in the same day, a twice-daily training setup, a tournament with morning and afternoon matches, every percentage point of glycogen recovery within that window matters. The additive effect of creatine on glycogen resynthesis, on top of adequate carbohydrate intake, is exactly the kind of marginal gain that separates recovered from under-recovered in high-frequency performance contexts.